In this video, I want to look at rearranging equations. The point of this was to notice that sometimes we get used to seeing things in a certain form, and it's helpful to recognize that they may not always look the same way. We can use properties of algebra to move things around within equations and have it still mean the same thing. For example, this first equation, t equals 0.06p. So one thing that we could do to this equation to make this look different is we could divide both sides by p. And so if I do that, on the right we'll end up with p divided by p. Those will go away and we will be left with t over p is equal to 0.06. So one other way we could write this equation is t over p is equal to 0.06. Similarly, what we could do is we could divide by 0.06. Because these two things are multiplied together, I can divide by either one of them and get a similar result. So in this case, I will divide by 0.06. Whatever I do to one side, I have to do to the other. And again, since 0.06 divided by 0.06 just turns into 1, it basically cancels each other out. We are left with t over 0.06 is equal to p. And so this would be the third way that we could write this same equation. So now I'll get my work out of the way here again. Notice that we have three different things, three different equations. 1, 2, 3, but they all mean the exact same thing. It's just written in a different way. So I'll do a couple other examples like this. I'm not going to show 3 examples for all of them, but just want to show some things that we could do. Again, in this one, I usually look for these pieces that are how I say attached, right? On the left, we just have c, but on the right, I've got a 225 and an n. It's actually 225 divided by n. So if I want to rearrange this equation, I'm going to get this out of the way a little bit just to help me do some work. If I want to rearrange this and make it look different, but still mean the same thing, one thing I could do is I could multiply both sides by n. I chose to do that because now I will have an n on the top and an n on the bottom. And so that means that n divided by n is 1. These basically cancel each other out. So we could rewrite this equation as n times c is equal to 225. And you don't even really need the multiplier in there. We could just say nc is equal to 225. Another equation we might change around is this third one here. So this looks a little different than what we've seen before. There's some subtraction in there. There's still some multiplication as well. So we'll look at a couple of different ways to do this one and some common mistakes that happen here. So what I would do is, again, I'm looking for a place where something is attached. I see this 4,000 is connected to the 50p by subtraction. So that's something I could do. And then I also noticed that 50 is multiplied by here as well. So I want to break up one of those connections if I want to move one of these pieces around. So what I would do, this is going to be your easiest approach, and we'll see why in a minute. I would add 50p to both sides. Because if I have a minus 50p and then I add 50p, that's just going to be 0. It essentially makes that go away. But again, I have to do the same thing on the other side. So those would cancel each other out, and we would be left with n plus 50p is equal to 4,000. So this is one other way we could write this. Again, let me just get rid of my work so I can show you a little different way. I'll just move this out of the way. This is one other solution. This is our, let's say this is our second solution. So one other thing that we could do, we could break up this 50p. As we said that 50 and the p is connected by multiplication. So we can always undo that multiplication. We need to be careful though. Since we have this subtraction in here, if I divide by p, if this is something that I'm going to do to both sides of the equation, I also have to do it to this term as well. So if I'm going to choose to make that move dividing by p, I have to divide each term by p on the right and the n by p on the left. So this would leave us with n over p on the left equals 4,000 over p minus 50. So whenever I see that subtraction in there, I tend to do it the first way, because this second way you need to be really careful and this can get confusing, but this is technically a correct third way to rewrite this problem. And finally, similarly to the previous one, the easiest way to rearrange an equation like this is to just subtract either of these pieces that are added. So I could, for example, I could subtract 80t from both sides, and that would be a nice easy way to rewrite this equation. So we would end up with h minus 80t equal to negative 16t squared plus 4. Be careful when you do something like this. Students a lot of times want to try to combine these terms as h and this 80t. Remember, if they are not like terms, so meaning that like if this was an h, I would have one h and then 80 more h's. I could combine those. But since I have different variables, I can't combine them. So we just have to leave it as h minus 80t, and that's perfectly okay.